So, just a couple vocab terms at the top. Just an event is the set of all outcomes that you're looking for. So if you say probability of this happening, whatever would fit into that category is considered an event. And what they call the sample space is all the possible outcomes that could happen. We'll do some specific examples, so this will make a little bit more sense, hopefully in a second. And just in general, probability measures the likelihood something is going to happen. All right, and just for some notation, if you guys see a P and then parentheses like that, you're going to see that all the way down the page. This means probability, if I can spell, of whatever's in the parentheses. That's just what that means. It's just instead of writing the word out, probability, you'll see a P and then whatever's in the parentheses, that's what you're going to find the probability of. Probability is always between 0 and 1. Sometimes you'll write it as a fraction, sometimes you write it as a decimal, depends on how the question might ask. Or it can also be written as a percentage, 0% to 100%, using maybe the decimal version to convert that if you need to. Okay, probability of an event that cannot happen. So this says an impossible event has a probability of 0. So something like that would be, like if I rolled a die, just a normal die, and I said, hey, what's the probability I roll an 8? You'd be like, Miss Grody, it only goes up to 6. So that would be an example of something that has impossible probability. An event is certain to happen, is going to have a probability of 1, and then actually both of these, like, so this could be 0% or 100% for either one of those. All right, something that has a probability of 100%. If I said, I'm going to flip a coin, what's the probability I get heads or tails? Then you'd say 1, because it's got to be one of those two, just as a little example. All right, theoretical probability is number of outcomes in whatever your event is, divided by number of outcomes in your sample space. Whatever your event is. So like I was just mentioning, if I said probability, well, we're going to do some examples so we can write these down so you can see what I'm talking about. But this is going to be theoretical probability in general, also called uniform probability model. You guys might see that in the math Excel. They also call it that, theoretical probability. It's also called uniform probability model. It's what should happen. Like just what you think should happen. So we're going to talk about that here in a couple examples. Okay, if you just have a normal coin and I flip a coin, can anybody tell me what the sample space would be? What are all the possible outcomes if I flip a coin? I would think. Yes. Okay, so this is just heads or tails, right? I'm just going to write H and T. Okay, theoretically, so like what you think should happen. If I flipped a coin, what would you tell me the probability I would flip heads over? 50%, right? Be one out of 2. One event out of the 2 options that are in my sample space has 2 options. One of those is heads. You could write this as 0.5. You could write this as 50%. Any one of those is acceptable if it doesn't specify in the question. Would tails be the same? For sure, unless we had a weird coin, which we're going to pretend we don't have any kind of a weird coin or anything like that. So these guys are going to be the same. All right, now think about rolling a die. So if you take just a normal dice and you rolled it. Okay, what is the sample space if I roll a normal die? What could I get if I rolled a die? Yes, 1 to 6, right? So 1, 2, 3, 4, 5, 6. So in my sample space, right, there are 6 possible things that could happen. So that would go on the bottom of the fraction if we were doing a probability. What should be the probability if I rolled a die that I would get a 1? Yeah. 1 out of 6, right? 1 is one of the options, and there are 6 total options, so it'd be 1, 6. What would be the probability I did not roll a 6? That's kind of tricky. What do you think? Yeah, all the other numbers, so this would be 5 out of 6. What is the probability I would roll an odd number? 1/2. Yes, if you think about it, your odd numbers, right? You got your 1, 3, 5. So it'd be 3 out of 6, and we would reduce that to 1/2. Is anybody having a question? Okay, now this one is a spinner. All these little spots are equally spaced. And I know, sorry, it didn't come out great on this copy, but this is a 1, this is a 1, this is a 1, and this is a 5 here, if that's hard to read. And I know this is weird, so I have 1, 2, 3, and 5. Those are all the numbers on the spinner, but some of them are repeated. If you're writing out a sample space here, you have to write out all the possible options. So I have a 1 on there, but I have a 1 on that spinner 3 times, so I would have to write out 3 1s for my sample space. I have 2 2s, so I would have to write 2 2s if I'm writing the sample space. We have 2 3s, and then we just have 1 5. So we have 8 total things on that spinner. They would all be equally spaced there. What is the probability I would land on a 1? 3/8. That's all you gotta do. 3/8. All right, what's the probability I would land on 2 or 3? 4/8, right? You got 2 2s, 2 3s, for either or. This would be 4/8, reduce that to 1/2. What about the probability I'd roll a 6? Or I'm sorry, spin a 6, I guess. You don't see a 6 on there, right? So that'd be a probability of 0. Okay, now, what's the probability I would roll a prime number, or spin a prime number? Does anybody know, before we answer this, what a prime number is? Do you guys remember? Like, what is a prime number? What do you think of when you think of a prime number? Yeah. Right. Exactly. So prime number just means it doesn't have any factors other than 1 in itself. So, let's see. 1's a prime number, right? 1 times 1. 2 is actually a prime number as well. 3's a prime number. 5's a prime number. I know 7's not on here. I'm just writing some examples for you guys. 7 would be a prime number. 9 would not be a prime number because 3 times 3 would be 9. So the next prime number would be 11. We could keep going. 2 is the only prime number that's even. So if I spin that spinner, what's the probability I'm going to spin a prime number? 100%, because they're all those on that spinner are prime. So this would be 1, or if you want to write 100%. Any of those are fine with me. Okay, is anybody having a question? So theoretical is what you think should happen. Now, experimental probability. This is based on either data that's given to you in the problem, which is mostly what we're going to do, or you would actually perform an experiment. All right, so it's based on the data given to you or results of an experiment, like you would collect the data yourself. So it's still number of outcomes in your event. So for example, let's say I flipped a coin. Well, we're going to use this as an example in a second. Number of outcomes in your event that you want. So if I flipped a coin, like do I want heads, do I want tails? Out of the number of trials that are performed. So this is different than theoretical probability. This is totally going to be based on either an experiment or data, but it's still going to be number of outcomes you want divided by the number of trials. So here's my little tiny example just to show this to you. It says you flip a coin 10 times. We would think, right, we should get 5 heads and 5 tails. That's the theoretical probability. The experimental probability, they just wrote, just real basic, just wrote the results here. You got heads 7 times and tails 3 times. So based on the experiment, the probability I would get heads would be 7 out of 10. The probability I would get tails would be 3 out of 10. So it's not based on what you think should happen, it's based on whatever data you have or whatever experiment that you perform. Okay. So, you guys, I don't know if you might want a calculator for some of these, but maybe not. So basically, I'm not going to have us do an experiment at the moment. I'm just going to give you guys some data. So here's what this says. This teacher conducted a survey to collect the eye colors of all their students, and here's the results. So we got 12 people blue eyes, 58 people with brown, 2 people with green, 8 people that have hazel eyes. If I'm going to calculate a probability here, what's maybe the first thing I should do? Yeah, how many people is this? So if we add all these guys up, how many people do we have here? 80. Okay, that should go on the bottom of every fraction. Now we might be able to reduce it or write it as a decimal, totally up to you. But then we need that because that's basically like the number of trials there because we have 80 people. Okay, what's the probability I randomly pick somebody out of this teacher's classes and they have blue eyes? How would I figure that out? Randomly pick, don't worry about reducing a fraction or anything. If I randomly picked somebody, what's the probability they have blue eyes? Perfect. Okay, now, totally up to you. 12 over 80. If you want to grab your calculator, do 12 divided by 80. And then I'm going to write the decimal just underneath here so you guys can see it. So as a decimal, is 0.15. And if you want to reduce that fraction, either one of these is fine. This is going to give you 3 over 20. So you can write it as a fraction, you can write it as a decimal. If you want to write that as a percent, that would be 15%. All right, so what would you say to me if I told you what's the probability I randomly pick somebody with brown eyes? Yeah, 58 over 80. And then I'm just going to divide that real quick, see what it is. Yeah, 0.725 there. And if you want to reduce the fraction, 29 over 40. So the green, right? We got 2 people with green eyes, 80 total. Reduce that, that'd be 1 over 40. Let me see what that is as a decimal, just so we can jot it down. This is 0.025, so it'd be like 2.5%. And then hazel, we got 8 people out of 80. That would reduce to be 1/10. So as a decimal, just 0.1. Okay. Now, how would I determine the probability the person had blue or green eyes? What would you do to calculate that, blue or green? Yeah. Exactly right. We're going to add these two. So you got 12 people with blue, 2 people with green. You don't do like 80 over 80. You just keep it, so 14. Oh my gosh, I almost wrote 18. 14 out of 80. So whatever that decimal is, let me see. This is 0.175 as a decimal. If you want to reduce that fraction, this is going to be 7 over 40. Okay. How would I determine, I randomly select a person and they do not have green or hazel eyes? And there's a couple ways you could do that. How would you determine if somebody does not have green or hazel eyes? Exactly. Okay. So green and hazel, but you're close. It's going to be 80 minus 10. So you're good. 80 minus 10. That's one way you could do it right there, which would give you 70 out of 80. Was anybody else thinking about doing it a different way? Yeah. Yes, you can add the blue and the brown together. That would be the other way to do that. Either way, if I do 12 plus 58, that's 70. Or if I do 80 minus these 10 people, both of those will give you the same answer. This is 7/8. And so if you want to write that guy as a decimal, this is 0.875. Does anybody have any question? Okay. Now, this is also going to be experimental probability based on some data, but I'm putting the data in a little different format. This guy's called a Venn diagram. So I just want to see if you guys understand how to read this real quick. It says all the members of a club are asked if they eat apples, that's the A here, or if they eat bananas, that's the B. And the results are displayed in this lovely Venn diagram. So if I just said to you, like, tell me what the 17 means, what would you tell me? What would the 17 in that circle mean? Yeah. Yeah, these people eat apples. What would you tell me the 20 is? These people eat bananas. What would you tell me the 52 is? These people eat both. So that little overlap shows that those 52 people, they would eat a banana or an apple. What is this weird 41 that's down in the corner? Neither. These people would not care to eat a banana or an apple. Okay, now how would I figure out how many people are in this club based on the Venn diagram? You're just going to add, yep, you got 17 people only eat apples, 52 that'll eat both. We got 20 that will only eat bananas, and then 41 that won't eat either one. So you got 130 people here. I need that because that's going to go on the bottom of my fraction for any of these probabilities. Okay, what would you do to set up a probability to figure out the probability you randomly select somebody from this club and they eat apples and bananas? That is going to be that overlap there. So 52 people will eat both. All right, so I'm just going to take that, figure out my decimal here. This is 0.4, and if you reduce that fraction correctly, it should reduce to 2/5. All right, now this one's kind of tricky. How would you tell me the probability, I'm going to randomly select somebody from this club, that they would eat bananas? How would you figure that one out? And it's not 20 over 130. Go ahead. Yes, good. Okay, so 20 people only eat bananas, but these 52 people will eat both pieces of fruit. So you're going to add those guys together. So if they eat bananas, the 52 that overlap there in the middle, and the 20 that only eat bananas, so out of 130, so you get 72 out of 130. Let me see what that is as a decimal real quick here. Ooh, this is not a nice decimal. Now, if you guys are doing this, here, I'll show you real quick on my screen here. Most of the questions on the Math Excel, if they ask you for a decimal, they'll ask you to go out 3 decimal places. So that's just what I'm going to do right here. The other decimals I've had have all been nice decimals as we went through the examples today here. So I would write 0.554 just to practice. So 3 decimal places is going to be what the Math Excel will ask you if it asks you for a decimal instead of a fraction. If you want to reduce that fraction, 36 over 65. All right, does anybody have a question? Now, the last one is geometric probability. So, geometric probability, you're going to calculate area of your event. So, the area of what you want divided by the total area of the figure that you're working with. So, we're going to use a little example down here at the bottom with the bullseye to kind of go through the geometric probability here. But it's the area you want divided by the total area of the figure. All right, so little tiny throwback from geometry here, just in case you need this. Area is what you use for geometric probability. So I have a circular dartboard here, so just in case, area of the circle is pi r squared. Okay, now, trust me when we do this, I'm going to leave this in terms of pi, and it's going to make it easier to work with some of these problems. But if you look at my bullseye here, in the middle, this is 20 points, and then each concentric circle around there is spaced evenly. Each circle that's outside that bullseye goes 2 inches in the width. The radius of the center of that circle where the bullseye's at is 3. If I asked you to find me the area of the entire dartboard, right, all I need is the radius. Can anybody tell me what the radius of that whole figure would be? So if I started at the center, go all the way out to the edge, what would the radius of that entire dartboard be? Yeah, 9, yeah. So like you start 3 here, right? And then this would be 2, this would be 2, this would be 2. Just add those guys up. Your radius of the whole thing should be 9. So all we have to do for our area of the whole thing, because this will go on the bottom of our fraction, pi times our radius, which is 9 squared. Now, to leave this in terms of pi, you literally just don't actually multiply by pi. So I'm going to square the 9. That would be 81, but we would write that as 81 pi. And don't worry about labeling, like it would be inches squared, but don't worry about the label for the moment. We're just going to put that 81 pi on the bottom of our fraction. Okay, now if I randomly throw a dartboard at this, or a dart at this dartboard, what is the probability I would land in the 20-point spot, which is the bullseye? So I got to find the area of the bullseye. What would you tell me the radius of the bullseye is? Just 3. Okay, so all we're going to do, so area of this is just going to be pi times 3 squared, which is 9 pi. Now, to do our probability, it's just the area of what we want, which is that center part that's shaded in there, 9 pi, and then I would divide that by the area of the whole thing, which is the 81 pi. And this is why I had you guys leave it in terms of pi, because the pi's actually cancel each other out. All right? Now, I can also reduce 9 over 81, so just 1/9 would be my probability there that I would land on the bullseye if I randomly threw a dart at that dartboard. All right, now the other part here I think is kind of tricky. I'm going to color on my picture just a little bit. So this says I land in the 5 or 10-point region. So I'm just going to color this real quick so you can see. This does not include the bullseye. So I'm just doing this, the 10 and 5-point area does not include the bullseye. So it'd be those two lovely concentric circles around there. How would I figure out the area of what I just colored with my yellow highlighter? Does not include the bullseye. How would you figure out that area? Yeah. Yes, yes. Okay, we're going to subtract the middle. Okay, so just ignore that outside edge. What would be the radius of just to where the yellow stops? Can you guys tell? So not that outside circle, because that's not part of it, but if 7. Okay, so if including the bullseye, right? So area of that area, including the bullseye, would be pi times 7 squared. So it'd be 49 pi. So that's going to be the yellow part and the bullseye. I know the bullseye from doing the previous question, so I'm going to just subtract off the bullseye. That was 9 pi, right? So if I subtract that off, and this is like terms, so this is super nice for us, this is actually just going to be 40 pi. That would be the area of just what I have colored in yellow, does not include the bullseye. That's the area of what I want. So to do my geometric probability, we're just going to put that guy, 40 pi, over 81 pi, which was the entire dartboard. And again, this is why I want you to leave it in terms of pi, because the pi's cancel, and this actually doesn't reduce, so this is just your answer. 40 over 81. Does anybody have a question? Okay, so the piece of paper I just gave you, that has the experimental and the theoretical probability, and when you get to the end of it, there's just a couple questions on Math Excel that'll be the geometric part of the probability. They had some better questions on there than what I could find to put on that paper. So do that set of questions there and the set of questions that are on Math Excel. It'll tell you that at the end of the worksheet. And if it doesn't say, you can write your answer as a fraction, you can write it as a decimal, you can write it as a percent, whatever you like better. That is totally fine with me.